Hi, we continue the increasing annuities, and this time example for corollary. So example, calculate the present value when I is equal to 3. Okay, so the question is the present value of this cash flow. We have the 20 years, so time 0 to 20. And I is equal to 3%. And the payment amount is 100 at time 1, 103 at time 2, 106 at time 3. And the last payment is $157. So we want to calculate present value of this. So in corollary, okay, so before that, so this cash flow is typical for annuities because the price level goes up every year. So if we approximate that as a linear function, it's natural to have a product which pays a certain amount in the first year, but the amount increases by a constant amount each year. So what is PV? So in corollary, we can set P is equal to 100 and Q is equal to 3. So P is equal to $100 and the Q is equal to $3. So remember that the P was the initial value and the Q is the increment. So this is initial and increment is $3 plus 3 always. So present value. So remember that by the formula. So this is the P times A right angle 20 because we have 20 payments in this cash flow at 3% plus Q times A right angle 20 at 3% minus n times v to the power n. So n is 20 here. So 20 times v to the power 20. So v is actually the 1.03, the inverse. So the 1 over 1.03. So to the power 20. So the 1.03 to the power negative 20. And over I is 0.03. So you can calculate this quantity by BA2 plus. So N is 20 and the payment amount -1 and the interest rate is 3%. So that is, so present value of these 20 payments of $1 each. So it's less than $20. And actually this becomes $14.877. And plus 3 times the same amount minus 20 times 1.03 to the power -20. So this becomes 0.55368 over the 0.03. So this becomes 1,487.7 plus 380.40. So this becomes $1,868.1. So in this way that we can evaluate the present value of increasing or decreasing annuities.